Hi, welcome back. We're up to Lecture 12 here in Statistics 1, and in Lecture 12 we'll do mediation and moderation analyses in R. So the emphasis this week has been on mediation and moderation, but today I'll walk you through how to write a script in R to actually implement both mediation and moderation analyses. So as you might expect, this lecture is organized into just two segments. In the first segment, we'll write a script to do the mediation analysis. In the second segment, we'll write a script to do the moderation analysis. And I'll use the same example data that I've been using all week, predicting happiness from extroversion, diversity of life experience, and socioeconomic status. So in this first segment, we'll do the mediation analysis. And again, to be clear, to test for mediation, all we need to do is 3 regression analyses. Of course, we'll want to test for all the assumptions first before we conduct those 3 regression analyses, but that's all we have to do is 3 regressions. The first is just the outcome as a function of the predictor. Then we want to look at the predictor as a function of the mediator, and then we want to put both the predictor and the mediator in the regression equation predicting the outcome. Now, with respect to R, we're going to use that LM function again, linear model. That's how we do our regressions. And we're just going to do 3 of them. We're going to do Y, predicting Y from X, predicting X from M, and then predicting Y from both X and M. And as I said, I'm going to use this same example that we've been using all week, where we're predicting happiness from extroversion, and in this example, just diversity of life experience. So we went through this example in Lecture 10, where we showed that diversity of life experience was a partial mediator of the relationship between happiness and extroversion. And we walked through how to represent that in a graphical model. But here what we'll do is I'll show you how to do that in R, and we'll write out the script. So the data for this example and for this script are available on the website. That's the name of the file. So you can download that file and then just play along with me, write your script in R, and by the end of this lecture you should have a script that runs the mediation analysis on these data. As always, we're going to start out the script by writing some lines of code that are just comments. So I just put in some examples here. So this is, again, Statistics 1. We're in Lecture 12. Here's an example where we do mediation. And there's my variable names. The first thing, again, as always, in these scripts, what we're doing is just using the read table function to access the data in that file and put it into an object in R. In this case, it's a data frame, and I'll just call it MED or MED for mediation. And again, remember this header equals true. That's there because the top row of my data file doesn't actually contain data. It contains information about the data. It contains the variable names. So we have to put in header equals true. The first thing I'm going to do is test several of the underlying assumptions. Right, so I'm assuming that these variables have univariate normal distributions. So how do I test for that? I can just run descriptive statistics. I do that using the describe function. And I can look at histograms. I'm not actually going to replot all that stuff here because we saw it in Lecture 10. You've done it way back when we did descriptive statistics. But just it's in here and it's in the script just to remind you that these are the underlying assumptions and this is how we test for them. I tested for them in these data. I made up the data. So we don't violate any of the assumptions here, but you should check just to be sure. Again, we're doing regression analyses, so there are assumptions beyond the univariate distributions. We want to test to see if we have linear relations among these variables, among all 3, X, Y, and M. And we want to test to see if we have homoskedasticity. And the best way to do that is to look at the scatter plot. So here's the code that we use to look at the scatter plots. Again, I'm not going to walk through them all here because we did that in Lecture 10, but you can look at them. You could also look at your residuals, save your residuals, and see if they're a function of any one of these variables. They shouldn't be if we have homoskedasticity. Okay, so this is the guts of the mediation analysis. It's just these three regression models. And the first one, all I'm doing is just predicting the outcome from the main predictor, what I was using as X and Y in my notation at the beginning of this segment. So we're predicting happiness from extroversion. And then I'll just do a summary of that model. Let's call it model 1. That's the direct effect. In model 2, I'm looking at the relationship between the proposed mediator variable and the predictor. So there I'm going to use what was the proposed mediator variable, diversity of life experience, as the outcome, and extroversion as the predictor. I'll do summary of model 2. Then model 3, we put both the predictor and the mediator in the equation together and see what happens. The other part of this that I don't have at the bottom here, but you'll see in the final script, is I then ran a Sobel test, which tests the significance of the indirect path. And we'll see that in a moment. Okay, so here's the R output from that first call to the LM function. So this is the first model, just looking at the direct effect between extroversion and happiness. And as we saw in lecture 10, this is a significant effect here. So if we look at the regression coefficients here, that's how I'm getting these values that I'm plugging into the regression equation. Okay, so the regression constant, or the predicted score on Y when X is 0, is 2.19. And then the regression coefficient indicating the slope or the strength of the relationship between extroversion and happiness is 0.275. So for a 1 unit increase in extroversion, we predict an increase of 0.275 in happiness. And if we look at the t-value and the p-value, we see that that's significant. Now let's look at model 2. This is where we're predicting the proposed mediator variable, diversity of life experience, from the predictor. And here you see the estimates. That's where I'm getting the numbers for this regression equation at the top. And here again we see, looking at the t-value and the p-value, that extroversion is a significant predictor of diversity of life experience. For a 1 unit increase in extroversion, we predict a 0.284 increase in diversity of life experience. So the question that we posed in lecture 10 was, well, does diversity of life experience partially or fully or not at all mediate the relationship between extroversion and happiness? So to test that, we put both extroversion and diversity in the regression equation together with happiness as the outcome. And what we see, looking at the regression coefficients and the corresponding p-values, is we see that this direct effect between extroversion and happiness is still significant, but we also see that the effect of diversity on happiness is significant and positive as well. What this is suggesting is partial mediation. I'm saying it's partial. Why partial, not full? Well, because of this piece right here, the 0.22, and the fact that that's still significant. So the direct effect is less than it was before introducing the mediator, but it's still significant. So that direct path that we're looking at isn't completely eliminated, it's just reduced. So that's evidence for partial mediation. The one extra thing we can do to test that more directly is do what's called the Sobel test. And what the Sobel test does is it tests the null hypothesis that the indirect effect through the mediator is 0. And what we get here for the indirect effect is 0.05. That's a little bit hard to interpret, so let's look down at the z-value. The z-value is 1.88. And if we did this as a directional hypothesis, which is legitimate, I had a theoretically motivated prediction about which direction this would go in, then the p-value associated with that is 0.03. Then we know that with a z of 1.88, and that's just over the line of significance if we did it as a directional test. If we wanted to be more conservative and do a non-directional test, then the z-value associated with p of 0.05 is 1.96. So we didn't quite reach that. So this would have to be done as a directional test to claim that the indirect effect is significant. So it's right on the border. But it's certainly fair to do a directional test in this example because the theory was predicting positive relationships across the board. So to wrap up this segment, here's the final script. I chopped it up into 3 sections. Here at the top are the comments, the data file that we read in. I had to load another package, so I had to load the multi-level package. We've been using the psych package all along, but the multi-level package has the Sobel function in it, so I needed that. So remember how to load a package. You have to do install.packages, open parentheses, open quotes, multi-level, close quotes, close parentheses, and then load that package by doing the library function, as I've done here in the script. Then I looked at descriptive statistics. In the second piece of this script, this is where I tested all the assumptions by looking at graphics. So I looked at histograms and I looked at scatter plots. The histograms to test univariate normal distributions, the scatter plots to see if the relationships were linear and homoscedastic. And then finally, the last part is the guts of this. The most important piece for this segment in this lecture is the mediation analysis. So the 3 regression analyses, or the 3 regression models, followed by the Sobel test. And that's a new function that we haven't seen yet. That's the Sobel function. And I called that function and saved the results into an object called indirect, and then just printed the results of indirect, and that's what we saw in the output. So that altogether, you should be able to follow that along, type that all into your R editor, save that script, and you should be able to reproduce those results. And if not, I'm sure I'll hear from you in the discussion forums.